our university and in our departments, in each individual lab, we tend to have what we call journal club, which is where we get together to discuss particular journal articles and try to learn as much as we can from the methods that we use and the applications that might come from that, and specifically to try to learn good practices for writing journal articles, as well as if we're stuck on a certain methodology, we can't quite move forward on it. Sometimes just discussing the details of the methods of an article helps us to have the breakthrough idea. To say they got everything done except this one thing, and that's what we're wrestling with as well. And then on the chalkboard, suddenly the idea comes up, and we can make some progress in our methods. Other times, we tend to discuss the articles in a way that's very aggressive and not nice. To take a published article that all the reviewers eventually accepted and the editor accepted, and then we tend to tear it apart, which is sometimes constructive, to really kind of take something that's accepted in the literature and still realize you could do better. You could make a better product than that in your writing. And so sometimes we get very aggressive in our review of the articles, but it's just in our own discussion in-house with the idea that you can improve your own writing by realizing that this is an accepted work, but it still has flaws, it still has problems. So as Dr. Joshi was talking earlier, you can get things published for sure, but you can always do a better job of understanding why the publication is coming out, the way your methods are actually doing. So the nature of our journal clubs that we do in my lab, we can do it a variety of ways. Usually it's only about 12 people in the room discussing the article, so it's a little bit challenging to manage the same structure for this size of group. But my hope is that, and I'll show you in a couple slides here, we might have a guided discussion about the article. So not so much me lecturing to you about the article, because I assume you read it so well that you could lecture me about the article. That's the hope, at least, right? And also the argument is that the professor in these discussions is not the master of the article. They're just the facilitator. So the person who basically says, this is an interesting article, I'd like for you to read it. Let's have a guided discussion about it next week. And so you had it only for about 24 hours or maybe 36 hours. So then not enough time to fully digest it, but enough time to get a sense of the article and maybe the strengths and weaknesses. So I'll explain a little bit about the technique that I plan to use, and then we'll move into it a little bit. And at the end of this one article, we'll have a bit of a discussion about, is it a good article? Is it kind of a mediocre article? It still got published, so that means it's good enough. But what do you think about this? If you were the editor, if you were the reviewer, would you keep it or would you send it back for more work? Okay, so any questions before we get going? You're not sure what's coming next, right? This guy from the US, crazy ideas. All right, good. This is what we call keeping you on your toes. You can't be sitting back on your heels. You have to be ready. So this particular article, I realized after it was provided out to you that it didn't actually have its own citations within it. So you don't know how to find this article besides it being printed. That's because it came from the conference proceedings from an IEEE meeting. And so to find those, it's just found on PubMed. You can search for this item and find it on PubMed. But in the article print off itself, it doesn't tell you where it came from. It's just title, author, work. That's nice. How do you cite this thing? So this is the citation in case you want to use that or find it in that way. Also, just by way of kind of disclaimer, the IEEE meetings, as many of you probably know, they require very large abstracts, basically, that functionally become papers and manuscripts. And the benefit of submitting and presenting IEEEs is your work gets published as if it was a manuscript as well. So the review process is more aggressive, it's more thorough, and what comes out of that is maybe not the same as you might have if you just submitted to IEEE transactions in neuroscience, rehab, engineering, as a clear manuscript on its own. It's a slightly different process. So I'm not sure how familiar you are with the differences between those. But because of that, some of the detail that this article goes into is a little bit less than what might be expected in a full-fledged article with IEEE. Okay, so the next slide moving too many computers. So what I plan to do is I have basically a slide for each section of the article, and I want to propose the idea that this is basically a template or a framework you can use to discuss any article, not just this article. And so I'll step through the questions here first, and then what we're going to do is I'll ask you to shape up into groups of maybe 5 or 6 people and discuss each of these questions amongst yourselves and kind of talk with your group about what do you think about these questions. Is it this? Is it that? Why do you say that? I don't agree. Come to some consensus and then report back to the group about what you thought about these questions. So this is a very American style these days in the United States, is to have these sort of group discussions where then you report back to the group. I don't know if this is done in the Indian instructions classroom or not. Maybe not. So it's become more common in the US, partly because a lot of the students end up going to work for tech startup companies where they end up basically being in an environment where it's very loose, it's very fast, there's 5, 6 people in the room making decisions about what's going to happen, and they have a very aggressive discussion about things and then make a decision and move forward. So we can't necessarily make our students like that, but we try to get them to think critically about papers and discuss with each other to refine each other's ideas. So with any given article that you pick up, this is the way that as a reviewer and as an editor, I evaluate articles as for their quality, and each of the slides will have kind of similar quality review sort of questions. So the first thing that we'll look at is, what is the actual background and justification for this work? So does it actually have a justification, or is it just an interesting idea that the person came up with, but has no real reason? So this is the big question of so what? So you did this work, so what? What is it for? What's the reason for this? So give me some justification why you should have done this work. So it's a little bit after the fact when you've already received the article as a reviewer, because the person already did all the work and they're now trying to publish it. But you might consider it as more of a funding agency sort of decision. If you had to convince me of the merit of doing this work, how would you justify it? How would you convince me that it's important? So with that in mind, does the literature review in the introduction convince you of the importance of the area of study? And a lot of times you'll find that there's some clear answers of yes, a lot of clear answers of not really, and then most of the articles are like, well, they did an okay job, but I'd like to see more. Maybe it's because of the page limitation that they cut out some of the review that could have been done. So this is something we'll consider today for both of the articles we're talking about. And then considering moving on from there, what I usually teach this in my classes is that once you've built the background and convinced the person that there's a need for the work, that leads very clearly to what we call like a gap statement. So that you can say, given all this work has been done, still it's not known if this thing, or yet we still don't know the relationship between this condition set and its outcome. So we still don't know something. So then that leads very clearly to a statement of purpose. So given that the gap is X, our purpose is to fill it with Y, something like that. So the questions we'll ask is, have they made a good case for why there's a gap? And given that, have they provided a clear statement of purpose? If they have provided these two things, then that naturally leads in kind of a logic flow into, is there a clear statement of hypothesis? And so that question then leads to the alternative question, which is, if there's not a hypothesis statement, is there a clear statement of milestones or achievements that they plan to meet? So oftentimes when we review articles, we have to kind of clarify what sort of article is this? Is it a research article with hypotheses that can be tested with statistical approaches? So kind of a classical sort of physics, biology, chemistry sort of test? Or is it more of a design and methods development paper, which may be more of an engineering paper? So we have to sometimes, as coaching our students as to how to write these, we write a very different paper to the Journal of Biomechanics than we do to an IEEE journal, partly because the audience is very different. Sometimes it's the same audience reading each other's work, but the reviewers and the editors are a little bit more looking for a type of article. So we'll coach our students to try to write towards the right audience, not just the way you're thinking about it. And so then as a reviewer, you can start getting a little bit grouchy. If you read, in fact, this first paper, and you're looking for a hypothesis statement, you say, there's no hypothesis. This isn't even science. Well, it's not really true. It's more that it's not a hypothesis-driven question. It's more of a design methods development for the purpose of making something sort of question. So try not to get too aggressive about this if it's clear that they're actually setting out milestones to be achieved. It's more of a design effort. So we try to clarify between those two. Okay, enough of me talking. What we'll try to do now is, if you can, I don't know if this will be an uncomfortable experience for you. It may be, but it's okay. Anytime you experience some new training regimen, some exercise, it may cause a little soreness, maybe uncomfortable, but then you build, become stronger from that experience, right? So consider this a social and emotional and psychological stressor today. So I'll ask you to shape up into groups of 5 or 6, and if you can turn to look at each other so you can discuss. If you want to move tables, you can. And we'll just take maybe 5 minutes, 5-10 minutes at most, to discuss amongst your group, and then I'll ask you to come back and share the answers to these questions. Okay? Go ahead. So just a real quick clarification. The task, your homework assignment here is to answer these questions about this paper. Like, did they justify it well? Not, can you justify the paper? Does that make sense? So you're reading it as the critique, as the person who's critiquing the work, as the reviewer, or as the editor, or as the professor. Does that make sense? A little bit? Maybe just a few more minutes to discuss and get your ideas down about this. So then move on to the discussion of your answers. A few more minutes. You have to accelerate your discussion. Okay, just one more minute. And I would encourage you to maybe select a spokesperson for your group. Okay, that's time. All right, so that wasn't enough time. We want to continue to discuss till lunchtime, right? But we have other topics to move to. So this is the first chance to experience this, perhaps, for many of you. So it's not easy, and it's sometimes a little bit awkward, but it's okay. Basically, the sooner we can all get over that, the better. Because then the idea is you're throwing out ideas, and everyone else maybe has the same idea, and they say, "Oh, good, we're in the same place that you are." Or they may say, "I've never thought about it that way. That's really interesting. I've never heard someone describe it that way." So this is why we break up into the groups. So you're not just hearing from the person up front with the microphone, that you are coming up with your own ideas to complement each other's ideas. So there's not quite enough questions to fill everyone in the group. So if you don't get picked to discuss this time, you can breathe easy, but that means you get picked for the next section. All right? So for the first question, what is the background justification of this work? Does the review convince you of the importance of the area of study? So is there a group that would like to volunteer and jump straight into giving some response to this? If not, then that means I get to pick. Yeah, I think this group's ready.
We went through this paper, and as for like the questions, like whatever you are, what is the background or justification? They have given a justification over here as to why this work has to be done. Justification is being given, and then next point was like whether the authors have made a good case for why there is a gap in the literature. They have like stated three basic points. Like first thing was like control of impedance is not there, and like second point was considering body and environment as a dynamic couple. That was like another point, and there's one more third point regarding the internal impedance. So they have like given three basic points from the literature like to justify the gaps.
Okay.
And
let's pause right there. So that's good. We'll save some work for other people. So that's good. So I think that's a very good point that you brought up, that there's like three things they list out as these are the reasons for this work. And it's questionable whether that logic makes sense or not. I think they described it very clearly. It seems to lead one point to the next, which is a good way to try to write an introduction section, is to try to start with a story about the broad overall question, get to a more detailed section, and then a more detailed, all the way to the fine point of here's the gap. So yeah, good job. See, it's so easy. You just share your ideas, and then the teacher says good job. All right, so then regarding the statement of purpose and hypothesis, let's have one other group talk about that. Yeah, these guys right there. I think they're ready.
So, yeah, they have mentioned that there are three, answering the second question, that is there a gap in the literature? They have mentioned that, but the main thing that they are proposing over here is the approach. Their approach is a novel approach. They have mentioned that it's an open loop approach, and they are not using a closed loop. But why so? and why particularly using this approach? They haven't justified it like, quite well, I think. And then to go ahead, is there a clear statement of purpose? I think yes. Like the link. With this novel approach, they wanted to see whether they can use that the other thing that they are using. The path they are using is keeping the damping and spring thing, they are using. So they are keeping the stiffness as constant and using damper. So why haven't they used it the other way, or why particularly this way is still unclear, I thought.
So a little bit of a gap still
Yeah.
in that justification.
Yes,
Yeah.
yes.
That's a very good point to bring out, is that as the author, you can think that you've described it completely well, and you have made a thorough case. And so they say, therefore, I'm going to do this work. And therefore, I did this work. Here's the result, here's the conclusion. Thanks very much. But someone else reads it and says, yeah, you made a good case, except for, you didn't tell me why is it novel? Like, why is this different from what's been done before? Why did you not consider these other approaches that I know of, that I've read articles about, that are maybe equally as good? So that's a critique that can be brought up. Consider your own work as an author, and you think you and your advisor, your professors say, yes, it's good work. Give it to somebody else who's not involved in the project to look it over. Sometimes it's just the faculty that's across the hall that you're not working with, or it's another graduate student or something, who just gives it one more read and says, I like it, I like it, I like it, except why not these other things? Why didn't you list those out? So that's a good.
And there isn't a hypothesis statement over here. They're just giving some different kind of data so that we can use this kind of data further if we want to design a particular process in that manner. So there isn't any hypothesis statement in this article. So they're just they have mentioned different milestones and achievements further.
So their goals are
Yeah.
fairly clearly stated as to why they're doing the work, which fits more the latter, right? The
Yeah.
development.
Yes, yes.
Okay, good. So any other thoughts about these kind of first two responses? Is there anything else that you found or wanted to talk about that the two responders didn't hit? They pretty well covered it? Yes? I think so. Good job. All right. So the next section then, first of all, before, yes, sir. Go ahead.
As I said, the statement of purpose has not been mentioned in the introduction. In the journal writing, during the introduction part, they will leave a question of why it is not been mentioned. But the result they had mentioned, why it has been open. After the discussion part, they had mentioned why it is. Because of its introduction, they made it leave us a question of we had made this. And in the discussion part, definitely they will discuss why it is okay.
So do you think that's a good approach?
Maybe.
Maybe. That's a safe answer. That's a good answer. Always say perhaps, right? Yes. So I would argue it's not a good approach, because I think that you should clearly state up front that this is the case I'm making for this work, and here's what I think is going to happen. Therefore, I'm going to do the work. You can restate my hypothesis later. Since I thought this is what was going to happen, and I looked at the results and determined that I was wrong.
Initially,
now
they
it's
may
a
be.
discussion, right? And then other times you'll see a hypothesis written in the discussion that's actually a description of why they think what they observed happened. So it's a like after the fact hypothesis. So a post hoc hypothesis. Sometimes that hypothesis is being written for their future work, to say, since we observed these things in our own effort, we think this is the reason why, so we're going to test that idea in the next paper. So maybe it's better to have an initial hypothesis, some results to show whether that's supported or not, and then a follow-up hypothesis to indicate what the next study is going to be. Yeah, good catch. So that was one point I wanted to kind of ask or discuss before we move on to the next section. as I was walking around and kind of snooping and looking over your shoulders to see what you were looking at and what you were talking about, sometimes I noticed people were, maybe flipping through the whole article, which is fine because it reminds you of all the things you were reading and thinking, well, did they make a point later on? Like, is it in the discussion instead of the introduction? When we do these journal club efforts, we try to make it focused on just that section for a while. Like, did they do a good job in just that section? So just the introduction. And it's hard because you look at this and it's just about half a page. So how much discussion do you really need to have about half a page? That's a very critical section. So if you can look at that and read it quickly and say, they answered all these questions, I'm fine. Okay, then you move on. But if you read all those and you say, I don't know, seems like I'm missing some things. I don't like how they left all the literature out that includes my research. They can get a little grouchy and kind of stop thinking about the article and then later go on to the methods. So with that in mind, we'll move on to the methods. So here's the 4 questions I'd like you to consider about methods related to this paper as well as any paper. So are the necessary theories or models described sufficiently to understand the foundation of their approach? So in other words, do they just jump in and start saying, we did this, this, and this, and then show you the results? Or do they say, because of the overall assumption of this part of this model, we did these things? Or because there's a variety of models that could have been used, we chose this one because it was the best way to answer this question, or we chose this one because we just don't like all those others. So is that sufficiently described so you understand why the methods are working on top of that foundation? Second one, are the approaches thoroughly described? So if I say I used inverse dynamics, that's an entire methods section. But is that sufficient to describe what my approach was? Or if I say I used motion analysis, all right, you could say I used physics too. Like, that's not a very thorough method, right? So you want to be a little bit careful as an author to be thorough enough to describe to the author exactly what you did, but not so detailed that they go to sleep while they're reading it, right? So it's almost like reading a recipe card. If you can replicate what's on the recipe card, you can make the same good meal, right? So as a researcher, if you can replicate what the researchers wrote about their methodology, then theoretically you should be able to replicate that study. So that level of detail is kind of what we're looking for. The third question, are the approaches also described in an understandable manner to a broad scientific audience? This is a really hard one. So someone can very thoroughly describe their approach. They can derive every single function that's listed in there, and you can have 3 or 4 pages of just math. If it's appropriate to that article and to that audience, then it's a great method. But perhaps it's not appropriate to a broad audience of scientists. So that kind of requires you to understand who's the audience that these people are writing to. Are they writing to clinicians? Are they writing to engineers? Are they writing to computer scientists, mathematicians? And you can usually tell by the title of the journal, right? If it says clinical biomechanics, you know there should be some clinical interpretation in here. If they say IEEE Journal of Obscure Mathematics that no one knows about except me and my friend, then you know there's an audience of 2, right? So you want to kind of understand what audience they may be writing to so you can judge whether they've done a good job of reaching that broad audience. So it's a trade-off. If you give very high detail, it's hard to make sure that the broad scientific community understands it. But if you give too much of an overall kind of vague description to make it readable by everyone, including your grandmother who's never done science, then maybe the detail-oriented people are upset because they don't think you know what you're talking about. You say, I used physics and I got these answers. And they say, yeah, right. Sure, what kind of physics did you use? What kind of math? I don't agree with that choice. So you want to be careful to kind of shoot to the middle of that. Not too detailed, but not too vague. And it's a hard thing to reach the balance of. And then the last one, another option is it too specifically directed to the small audience? So kind of we were already talking about that. All right, so at this point, same group, don't move your chairs, just stay put with your group. Maybe the second article you can change partners. But for this one, if you can discuss these 4 questions, or 3, and then part 3A and B, just for the method section, and come up with some solid answers, and we'll discuss in another 5-10 minutes. Okay? Good job. Cool.